Hello everyone. So today we are going to see about grid search hyperparameter tuning. So basically, the hyperparameter tuning is like finding the best parameters for the model. And the technique grid search is like we are giving a set of values for parameters and finding out the best values from the grid. So basically, we are going to see an example. The data set which we are using here is based on experience. We are finding out the salary. This is a regression problem. I have a data set here.
Salary line. Salary B. Years experience cropped A1. 1.1 A2. 1.3 A3. 1.5 A4.
So 1.1, 1.3, 1.5. So this kind of years we have, and then a salary in other column.
1 year. Salary B. 39,300. 46,000. 37,000.
So this kind of salary values we have based on experience. We are finding the salary. So based on the past data, we are training and finding out for a new given experience, what will be the salary. Okay. So we will load this data set and we will do all pre-processing, create model with hyperparameter, and we will do the prediction. Let's go into notebook.
Module. Screen sharing meeting. C colon backslash. Screen sharing. Module 5. Toolbar. Chrome menu button sub. C colon backslash Windows backslash toolbar. Chrome menu button sub. Module. Clickable in left bracket. Clickable in top menu navigate. Clickable out of edit. Clickable import pandas is from Sklern. Model line selection import train line test line split comma. Grid search CV from. Sklern.tree import decision tree regressor from Sklern.metrics import mean line absolute line error comma. Mean line squared line error comma. R2 line score. Clickable in left bracket.
So we are importing the necessary packages. Basically, we are going to use a decision tree model in this notebook, and we will do the hyperparameter tuning for it.
Edit multi-line. Out of edit clickable number 1 dot. Load the data dataset equals pd dot read line csv left paren. Tick salary line data dot csv tick right paren. Clickable in left bracket 3 right bracket colon.
So we will load the salary data set with pandas.
Edit multi-line. Out of edit clickable space. Clickable no indent number 2 dot. Split the data. Edit number 2. Oh. Untitled dash no. Untitled dash.
So then we do this train test split, 80% data for training and 20% for the testing, so that we can evaluate based on test set.
Number 2 dot. Split the data into training and testing sets left paren. 80% train comma. 20% test right paren. Rate boost on. Rate 15. Rate pit volume volume 6. Number 2 dot. X equals dataset left bracket tick years experience tick right bracket. Y equals dataset left bracket tick salary tick right bracket. X line train comma, X line test comma, Y line train comma, Y line test equals train line test line split left paren, X comma, Y comma, test line size equals 0.2 comma, random line state equals 42 right paren, blank, blank.
So we are doing this train test split with 20% test data.
Module. Click out of edit clickable number 3 dot. Define the model left paren, edit, number 3, start, blank. Number 3.
Now we will define the decision tree model.
Number 3 dot. Define the model left paren, decision tree regressor right paren. Model equals decision tree regressor left paren, right paren, blank, blank.
So yeah, we will create object from the decision tree.
Module. Clickable, out of edit clickable number 4 dot. Define hyperparameters for grids, edit number, start, blank. Number.
So we have to define the hyperparameters for grid search, so that we will give list of values. It will find out the best value out of it.
Number 4 dot. Define hyperparameters for grid search. Param line grid equals left brace. 4 space tick max line depth tick colon, left bracket none comma, 3 comma, 5 comma, 10 right bracket comma.
So for example, this max depth is one of the hyperparameter. We are giving like a value none, 3, 10. So this one of these values might be the best for us. So we are giving each parameter and their list of possible values.
Tick min line samples line split tick colon, left bracket 2 comma, 5 comma, 10 right bracket comma. Tick min line samples line leaf tick colon, left bracket 1 comma, 2 comma, 4 right bracket, no indent right brace. Blank, blank.
So we given 3 parameters and a list of values according to it.
Module. Clickable edit out of edit clickable space. Clickable no indent number 5 dot. Set up grid search CV for hyperparameter tuning grid line. Edit number 5 dot. Start blank. Number.
So we will set up this grid search based on this grid value.
Number 5 dot. Set up grid search CV for hyperparameter tuning. Grid line search equals grid search CV left paren, model comma, param line grid comma, CV equals 5 comma, scoring equals tick neg line mean line squared line error tick right paren.
So grid search will happen based on mean square error. Every time it will calculate, I mean the combination of model will be created and this mean square error will be calculated. And then it will find out the minimum mean squared parameter as the best parameter for the model.
Blank, blank. Clickable, out of edit clickable number 6 dot. Train the model edit, number 6, start, blank. Number,
Based on this combination, it will train the model individually for each combination and calculate the MSE.
number 6 dot. Train the model, grid line search dot fit left paren, x line train comma, y line train right paren, blank, blank, blank. Clickable, out of edit clickable number 7 dot. Predict on the test SETI line pred equals, edit, numbers, start, blank.
So within it, it will find out the best parameters based on lower MSE. So that will be in the grid search object. Based on this grid search object, we can predict to the salary for the new experience.
Number 7 dot. Predict on the test set. Y line pred equals grid line search dot predict left paren, x line test right paren, blank, blank.
So this X test we are giving to get the predicted.
Y line pred blank, blank, out of edit clickable number 7 dot. Predict on the test SETI line pred equals grid clickable in left edit multi-line, out of edit clickable no indent number 8 dot. Evaluate the model me equals mean line absolute line error left paren, y line test comma, y line pred right paren, MSE equals mean line squared line error left paren, y line test comma. Edit number start blank. Number 8 dot. Evaluate the model.
So we will evaluate the model.
Number 8 dot may equals mean line absolute line error left paren, y line test comma, y line pred right paren.
So we are finding mean absolute error, which is the mean of the absolute difference of each data points which we predicted along with the actual and the predicted.
MSE equals mean line squared line error left paren, y line test comma, y line pred right paren.
So MSE we are calculating.
R2 equals R2 line score left paren, y line test comma, y line pred right paren.
R2 also we are calculating.
Blank, print left paren, quote mean absolute error colon quote comma, may right paren. Print left paren, quote mean squared error, print left paren, quote r dash squared.
So all the three values we are printing.
Print left paren, quote best hyperparameters colon quote comma, grid line search dot best line params line right paren.
So grid search or best parameters we are printing out.
Blank, blank. Module, make, art blank, print blank, out of edit clickable number 8 dot. Y, click, mean absolute error colon, 8823.
So mean absolute error is 8000.
Mean squared error colon, 1170.
So mean squared error.
R dash squared colon, 0.770.
0.77.
Best hyperparameters colon, left brace tick max line depth tick colon, 3 comma, tick min line samples line leaf tick colon, 2 comma, tick min line samples line split tick colon, 2 right brace.
So this combination of values are the best parameter.
Clickable in left, edit code, edit multi-line.
So this is about grid search and we found out the best parameter. This best parameter model we can use in the production. See this how it is running is like we have 3 parameter, each has 3 values in means 3 into 3 into 3. 3 into 3, 9, 9 into 3, 27 combination it will run and find out the best values. This is how grid search will work. The other technique is random search. We will see in the next class.